Good afternoon, students. Today we are going to be working on Lesson 7, which is going to walk us through how we replace letters with numbers. So this is really getting into our algebra unit and how we utilize letters, specifically in formulas today, that can stand to help us solve any expression that we need to. So looking at example 1 here, this shape is obviously a square. So our first question is, and you don't have this paper, you shouldn't have anything in front of you right now, you should just be listening along with me, and then I will tell you when to go get your packet. So the first thing this asks us is, what is the length of one side of this square? When we have a grid like this, we can count the length by counting these segments right here. So on this one, the length of one side of this square is 3. Then it says, what is the formula for the area of a square? So you have been working on area since 3rd grade. I know this because my daughter is currently in 3rd grade and they started area. How do we find the area of a shape? It's usually length times width, but in a square, all of the sides are the same. So the formula would be the side length squared. Another place that we can use exponents. So they're just saying one side, any side. It could be this side, it could be this side, it could be this side, it could be this side. It doesn't matter because all of them are 3. But to find that area, we can simply square the side and find the area. So what is the square's area as a multiplication expression? So the formula, should be, actually it should be A, area equals sides squared. So this is called a formula. Each of these letters is standing in for a number. When I say it stands in for a number, the area might be 6,342. That's one number. It has several place values to it, but it is one single number. So the area is a number which is equal to any side length squared for a square. That's the formula for area of a square. So now it says, what is the square's area as a multiplication expression? So in this case, this square's area as a multiplication statement would be 3 units times 3 units. So that's really the substitution when we replace the letter with numbers. So this stands for any square that's out there. It might be a tiny little square that is only millimeters big. It might be a huge square. It might be a ginormous square that's talking about a city block. So any square that you have, you can find that formula by substituting the number of one of the sides and squaring it. So in this case, we substitute 3 in and we square it and we get the area of 9 units squared. Again, there are no accidents in math. This is called 9 units squared because look, it literally takes 9 square units to cover that shape. And that is what area is when you cover a shape. So then it says we can count the units. And this one, it could have been easy. What's the area? We could have simply just counted 9, or we could have used the formula. But look at this square. Its side length is 23 centimeters long. That's just too many tiny units to draw. We'd have to go in there and draw 23 little lines. We're lazy. We don't have time for that. So what expression can we build to find this square's area? So that expression should be 23 centimeters times 23 centimeters. So what is the area of the square? Use a calculator if need to. So I could use my calculator. Make sure you read carefully in these because you might have options to use calculators. So 23 times 23 gets me 529. What does that mean? That means that it would take 529 squares that are a centimeter by a centimeter to cover this space. Do we have time to draw 529 squares? No. And this label would be centimeters squared. When they don't tell you what we're measuring in, we use the generic units squared. If they tell you a specific measurement like centimeters, meters, miles, inches, feet, yards, then it's going to be that measurement squared. So in this square, it would take 529 squares that were 1 centimeter by 1 centimeter to cover this space. So again, in this case, we had A equaled S squared. Our side length, S, stood for one number. It stood for 23 squared. A, again, stood for one number, 529. Although it has 3 digits, 529 is a number. Now you need to go get your classwork page from your teacher. She should have it up at her front table, or she would tell you where it's at, and you're going to complete the rest of these along with me. So pause until you have that paperwork. Once you have this paperwork, you're going to go ahead and complete exercise 1. These are not drawn to scale, which means this says the side length is 25 inches. Hopefully you realize this is not really 25 inches. That's probably not even 1 inch. So they're just giving you an example or a scale drawing that tells you this is 25 inches. So down here, you're going to fill out this table for these drawings, telling about the length of one side of square. So this row is going to be talking about square A. This row is going to be the information from square B. Square's area written as an expression is when we write it out, what times what. This is when we solve for it and actually find that area. When you have that completed, please check back to make sure that you are on the right track with me. If you're back with me, it means you have these filled in. So you know that the side length of square A is 4. The area written as an expression would be 4 units times 4 units. And then the area written as a number would simply be 16 units squared. For B, the side length is 25, so that expression would be 25 times 25, and that area would be 625 inches squared. Make sure that you're really using your labels in your classwork and on your homework tonight. It helps to make that meaning of area really pop and connect. Why is it units squared? Because we are doing an array that literally covers the shape. Now we're going to move on to example 2. So this is the blue rectangle that they reference when they say blue rectangle. I know you can't see it because it's not colored copies. So our first question is, what does the letter B represent in this blue rectangle? So here's the letter B. What is its value? What number is it representing? So since it's representing the width of this rectangle, and hopefully you've learned in the past that in rectangles, opposite sides are congruent or equal. If this side is 8 centimeters, then that means that B is also 8 centimeters. So B represents the length, and B would be equal to 8. Then it asks, with a partner, we're not going to get with partners today, answer the following question. Given that the second rectangle is divided into 4 equal parts, what number does the X represent? So again, you're problem solving here. These are all equal. So if this one is 4, what does X represent if it's covering 2 of them? So hopefully you said that your answer is 8. How did you arrive? Sorry, I'm up here. How did you arrive at this answer? Well, this is where we would explain if one rectangle is 4, 2 of them would be 2 groups of 4, or 4 plus 4. So again, working on explaining and really talking through that math, how did you arrive at this answer? I knew one length was 4, so X was 2 lengths, which is 2 groups of 4, or 4 plus 4, which would equal 8. So now it says, what is the total length of the second rectangle? And you're not going to tell a partner how you know, you're going to write how you know. So looking at this one, they want to know what is the total length. So length is down here. So if this is 4, how long is that entire rectangle? Hopefully you said it is 16. How do you know? There are 4 groups of 4, which is equal to 16. If the 2 large rectangles have equal lengths and widths, find the area of each rectangle. So we're kind of combining some things here. So if we know that this is 16 because it's 4, 4, 4, 4, so then the total length is 16. And if we know that this width is 8, that means this width is 8. So this width is 8, this length is 16, this length is 16 because they're congruent. The formula for finding the area of a rectangle, A equals L times W, or you'll often see it A equals LW. You'll see it written juxtaposition because, again, this X quickly looks like another variable that we're doing in there. So as we get more into our algebra unit, you'll see it more and more written as juxtaposition. So if A equals length times width, that means we need to do the area, and we're going to substitute in for our numbers. The length is 16. The width is 8, so 16 times 8 is going to give us 128 centimeters squared. Again, if they give you a particular measurement that we're working with, that needs to be your label. Don't just do the generic unit squared. If they tell you it's centimeters, then our answer needs to be in centimeters. So discuss with your partner how the formulas for the area of squares and rectangles can be used to evaluate areas for a particular figure. So we know that the formula area of a square equals S squared. And you should write anything that I have on my paper on your papers. So if we know that the area of a square is S squared and the area of a rectangle is length times width, we can use these formulas by substituting in any length that we have for a particular shape and then solving for those expressions. So your job now is to go ahead and do exercise 2 and complete the tables down here. It's going to be very similar to what we did over here. It does say using a calculator is appropriate, so I would use the calculator on your Chromebook. When you're done with exercise 2, go ahead and check back in to see if you were correct with your answers. All right, if you're back with me, it means you have this completed. So to find the length of rectangle A, I needed to count these segments down here, and there were 7 segments. So that's the length. The width, I count these segments here. There were 4 segments, so that's your width. The area written as an expression is 7 times 4. Written as a number, it's 28 units squared. Make sure you have that label. There are literally 28 squares that cover this space, making that the area. For rectangle B, we don't have time to draw 46 different squares and 32 different rows. The length is 46. The width is 32. Written as an expression, that's 46 times 32. Multiplying that out, it takes 1,472 square meters to cover this shape right here. So 1,472 meter by meter squares would cover this space. Make sure you have meter squared, not unit squared or any other label, because it was specific here. All right, go ahead and go to video 2 for the rest of your lesson.